In the diagram below, given that DE is tangent to circle F, what is the length of FE? All right, so we're looking for the length of FE right here. If DE is tangent, this line here and circle F, this is the center, this is a radius. The tangent line and the radius make a right angle. Okay, so now you're just using a squared plus b squared equals c squared because we have a right triangle. All right, so across from the right angle is always going to be c, the hypotenuse. So I'll just leave it as c, or c squared. A and b, it doesn't matter, so I'm going to let a equal 8 and I'll let b equal 11. A squared is going to be 8 squared. B squared is going to be 11 squared. And let's see, 64 plus 121, that's going to be 185 if I'm not mistaken. Let me double check. It's correct. And the opposite of squaring something is to take the square root. So you do that to both sides. Square root of 185 is just 13.6. And the square root of c squared is just c. So this side length right here, FE, is 13.6. Final answer. So remember for the tangent that it makes a right angle. Okay, here we want to do the perimeter of this triangle. All segments are tangent to the circle. Remember, when this tangent segments meet at the same point, they are congruent. So if this piece is 6.1, then this piece here is going to be 6.1. If this whole thing is 15.8 and this is 6.1, right here is going to be 15.8 minus 6.1. Okay, 15 minus 6 is 9. 0.8 minus 0.1 is 0.7. All right, if this here is 9.7, then this right here is going to be 9.7. If this whole thing is 14 and this is 6.1, then this right here is going to be 14 minus 6.1. Okay, so that's just 7.9, and this here is 7.9. All right, now you add up all the sides because it's a perimeter. Since we have doubles, we can just multiply each one by 2. Okay, 7.9 times 2. We're looking at perimeter P. 7.9 times 2. And then plus 9.7 times 2. And these two, it's going to be 6.1 times 2. All right, I'll do this mess on the calculator. And I get 47.4 for the perimeter. In the diagram below, what is the measure of arc AD? Okay, so if it just has 2 letters, AD, you go the shorter way around the arc. So from A to D, the shortest way is right here. From A to D, that's what we're looking for. All right, so for the vertical angles, you want to do the X shape. We got this right here and this right here. All right, I couldn't make it straight, but there you go. That's the X shape. So if this one is 65, the one on the other side is also going to be 65. All right, so the arc matches the central angle. This is 65, and this right here is 25. All right, so arc AD is just going to be 65 plus 25. And that equals 90. All right, so remember the central angle matches the arc angle or the arc measure as well. Okay, when they say measure, they mean the angle, usually in degrees. In the diagram below, what is the value of X? Okay, this is the center right here. And we have 2 chords, and notice the chords are the same distance from the center. They're both 10 units from the center. All right. And this is a right angle here because when you measure the distance of a segment, a point to a segment, it is the perpendicular distance. It makes a right angle. Anyhow, since these distances are both 10, then these chords, AD and BC, are going to be congruent. All right, so AD equals BC. All right, and AD is represented by this algebra expression. I know it looks like it's just pointing to this piece, but on the test I'll make it so this expression is the whole thing instead of just this piece right here. Okay, so this whole thing is going to be 4x minus 8. And that equals BC, which is just 24. All right, the opposite of minus 8 is plus 8. The 8's cancel. Bring down your 4x. 24 plus 8 is 32. The opposite of times 4 is divided by 4. And x is just 8. So remember, when the chords are the same distances from the center, the chords are going to be congruent, or the same lengths. In the diagram below, what's the measure of angle G? So here's angle G right here. All right. And we know that the inscribed angle is half the measure of the intercepted arc. So the intercepted arc, if you look at the ends of the angle, the intercepted arc is this arc right here. Now, we don't have it, but we could easily find it. We know all the way around the circle is 360. So if we just subtract these two from 360, we get this right here. All right, so this right here is going to be 360 minus 65 minus 114. All right, so I'll do this on the calculator to get the measure of that arc. And I get 181 degrees. So the inscribed angle is going to be half of the arc. All right, so the inscribed angle, the measure of angle G, is just going to be half of 181. So 181 divided by 2 is just 90.5. And that's in degrees. In the diagram below, what are the values of x and y? Okay, so we have a quadrilateral inscribed in a circle. Each point of the quadrilateral is on the circle. So the angles across from each other are supplementary. All right, so if I go across, 124 plus y is going to equal 180. Okay, these two combined equal 180. They're supplementary. So y is just going to be 180 minus 124. And that is 56 degrees. Same with the other two. X and the 101, the ones diagonal from each other, are supplementary. So x plus 101 equals 180. And x is just going to be 180 minus 101. And that, of course, is 79 degrees. So light work, as long as you know they're supplementary. They have to go diagonal from each other. In the diagram below, what is the value of x? All right, we see these are two chords and x is inside the circle. Okay, when it's inside the circle, you just add the two arcs and divide by 2 or multiply by 1/2. Same thing. All right, I'll try to give you this formula, but I can't always fit all the formulas. But anyhow, remember, when it's inside the circle, you add the two arcs and divide by 2 or times 1/2. Same thing. So it's going to be 1/2, 61 plus 123. And that's going to be 1/2. 61 plus 123 is 184. And if you take half or divide by 2, That's just 92 degrees. And the diagram below it is the value for x. Now the angle is outside the circle, and when it's outside the circle, you subtract and take 1/2. Okay, so x is going to be 1/2, and you have to put the bigger number first or you're going to get a negative. All right, so that's going to be 1/2, 67 minus 21. All right, and that's going to be half of 46. And half of 46 is just 23. All right, I'll give you these circle formulas on the test. EA times EB, so this times the whole thing equals EC times ED. This times the whole thing. And over here, EA squared, so this times itself equals EC times ED. This times the whole thing. In the diagram below, what is the value of x? Okay, intersecting chords, so it's pretty easy. Intersecting chords, we have 4 times x, and that equals 3 times 8. Solving for x, the opposite of times 4 is divided by 4. All right, you can do this on the calculator. 24 divided by 4 is just 6. You can do it in your head, some of you. In the diagram below, what is the value of x? Okay, so we have this times itself, so that's 7 times 7, or 7 squared. And that's going to equal this, which is 6, times this whole thing, which is going to be 6 plus x. 7 times 7 is 49, and distributing 6 times 6 is 36. 6 times x is 6x. All right, so we're solving for x. The opposite of plus 36 is minus 36. It cancels here. 9 minus 6 is 3. 4 minus 3 is 1, and that equals 6x. The opposite of times 6 is divided by 6, and it cancels here. So 13 over 6, rounded off, is going to be 2.2. So that is the approximation for x. What is the standard equation of a circle with center at -5, 3, and radius equals 8? All right, so I might not give you the formula for the circle, but the answers are going to be multiple choices. So this is h, this is k, and of course the radius is r. All right, so the formula is x minus h squared plus y minus k squared equals r squared. Okay, x minus h is going to be x minus -5. And y minus k is going to be y minus 3. And r squared is going to be 8 squared. I'll tell you what, I'll give you this formula. Okay, anyhow, 2 negatives make it positive, so that's x plus 5. Y minus 3 stays as is. And 8 squared is going to be 64. So you might not need the formula. If you look at the multiple choices, the -5 becomes +5, and the +3 becomes -3, and the radius is just squared. 8 squared is going to be 64. In the diagram below, what is the value of x? Okay, we have 7 times the whole thing, which is 7 plus x. And that equals 8 times the whole thing, which is 8 plus 10, or 18. I'll just write 8 plus 10 for now. Okay, distributing 7 times 7 is 49. And 7 times x is 7x. 8 plus 10 is 18. And 8 times 18 is going to be 144. All right, plus 49, the opposite of plus 49 is minus 49. And it cancels here. Bring down the 7x, and this is going to be 95. All right, this is x times 7. The opposite of times 7 is divided by 7. And 95 divided by 7 is 13.6, rounded off. All right, so I'll give you the formula for this one and this one as well, okay? And I'll make it so it's not a quadratic. 38, what is the area of the parallelogram below? Okay, I'll give you the formula, but the area for the parallelogram is just base times height. Remember, they have to be perpendicular to each other, so we're ignoring this right here. This is the height, and this right here is the base. So it's just going to be 8 times 12, or 12 times 8. And that's 96. And if there were units, the units would be squared. The triangle shown below has an area of 21. What is the value of the side length x right here? Okay, area for a triangle is 1/2 base times height. And they gave us the area. So we're just going to plug in 21 in place of a, and that equals 1/2 base times height. This right here would be the base. Okay, any side of the triangle can be the base, but we can see this height right here is perpendicular right there. So this has to be the base, and the 6 has to be the height. All right, so the base b is just x. And the height h is 6. Now, we could multiply both sides by 2 to get rid of 1/2. But if you have an even number here, you might as well multiply the 1/2 times the even number. These are all multiplied, so the order doesn't matter. All right, 1/2 times 6 is just 3, and we still have x, and that equals 21. The opposite of times 3 is divided by 3, and 21 divided by 3 is just 7. One diagonal of a kite is 4 times as long as the other. Its area is 68. What is the length of the longer diagonal? Okay, area for the kite is 1/2 d1 times d2. And it says one diagonal is 4 times as long as the other. So we can let the other diagonal equal x. And if the first diagonal is 4 times as long, that's going to be 4x. All right, so D1, the first diagonal is 4x, and D2 is just x. All right, it's 4 times as long. So if this one's x, this is 4 times x. And now we can plug into the formula. We said the area is 68. So that goes in place of A, and that equals 1/2. D1 is 4x, and D2 is just regular x. Okay, we can multiply both sides by 2, but we can distribute since we have an even number. So let's see, we have 68, and 1/2 of 4x, 1/2 of 4x is just 2x. 2x times x is going to be 2x squared. All right, we have 2, and x times x is x squared. All right. So we have 2x squared. The opposite of times 2 is divided by 2. All right, and it cancels here. So x squared is 68 divided by 2, and that equals 34. The opposite of squaring something is to take the square root. So the square root of 34 is just 5.8. But I did ask for the longer side. All right, I asked for the longer diagonal. So we have to take x equals 5.8 and plug it in. So that goes right in there, 5.8. All right, so D1 is going to be 4 times 5.8. All right, 5.8 times 4 is 23.2. In the diagram below, what is the area of the trapezoid? Okay, I'll give you the formula. 1/2 the sum of the bases times the height. It's basically the average of the two bases times the height. All right, so the bases are the parallel sides. We can see these are not parallel. So the bases are going to be the parallel sides. All right, so the area is 1/2 B1 plus B2 times the height, H. So the parallel sides are the bases. I'll let this one equal B1, and I'll let this one equal B2. All right, so B1 plus B2 is 18 plus 21. And that's times the height, H, right here. That's going to be your H. Now, why isn't it this side? Because H has to be perpendicular to the bases, okay? So this side is not your H. And let's see, 1/2, you can make it 0.5 if you want, or you can just divide by 2 at the end. But 18 plus 21 is 39, and that's a 12. All right, so 0.5 times 39 times 12, and that's 234. Okay, if you don't like 0.5, you can just divide by 2 at the end after you multiply these two numbers. Same thing. Given that the figures below are similar, what is the ratio of their areas? Okay, the ratio of the areas equals the ratio of the sides squared. All right, so the ratio of the sides, we can see the side lengths is 24 to 8. And that's squared. But before you square that, it's better to reduce. Okay, 24 divided by 8 is actually just 3, or the same as 3 over 1. And that's squared. So you want to reduce this before you square it. All right, when you square a fraction, you square the top and bottom separately. So that's going to be 3 squared over 1 squared. And 3 squared is just 9. 1 squared is just 1. And that's your ratio for the areas. So just take the sides, make it a fraction, reduce it, and then square it. All right, to the nearest tenth, what is the area of the sector in boldface? All right, so we're looking for the area right in here. I gave you the formula. The area of the sector is theta over 360 times pi r squared. All right, so theta over 360 times pi r squared. Theta is this central angle right here. That's a Greek letter. So that's 225 divided by 360. And that's times pi times r squared. The r is your radius right there. So that's going to be 9 squared. All right, I'm going to rewrite just so you're not confused, but these are both in the numerator with the 225. So it's 225 times pi times 9 squared. And that whole thing is divided by 360. All right, so I'll do the numerator first. Use the pi key, 225 times pi times 9 squared, hit equals, and then divide by 360 at the end. And rounding off, I get 159.0. All right, the units were in feet, so for the area, that's going to be feet squared. But again, it's going to be multiple choice, so the units should be in the answers. To the nearest tenth, what is the length of the arc in boldface? Okay, so we're looking for the length of this arc right here. Now, we know it's 135 degrees, but that's the arc measure. Okay, we're looking for the length. So the formula for arc length, theta over 360 times 2 pi r. All right, so I'll give you those formulas. Theta over 360 times 2 pi r. All right, so theta is your central angle right here, and r is your radius. That's just 7. All right, theta is going to be 135 divided by 360 times 2 times pi times r, which is 7. Now, rewriting, these are all numerators because you can put this over 1. So it's 135 times 2 times pi times 7. All right, that whole thing is divided by 360. So again, use the pi key. 135 times 2 times 7 times pi. Hit equals, and then divide by 360. Hit equals, and I get 16.5 rounded off. The units were in meters, so the arc length is also going to be in meters. It's just the length, so it's not squared, it's just meters. The area gets squared, but not the length. All right, surface area, the rectangular prism or box. So we know the area of the rectangle is length times width. So we'll take it piece by piece. Okay, we'll do the front, back. So the front here, we see the height is 4. That's 11. That's 4 right there. The height here is 4, same as the back. So on the front and the back, it's the same, but we'll just do the front. That's 9 times 4, which is 36. For the left, right here is the right. It's just 4 times 11. And that's 44. And for the top, bottom, let's see. The bottom is right here. That's 9 times 11. And that's 99. Notice we used each side length twice. We used the 9 twice, we used the 4s twice, and we used the 11s twice. Okay, so just add these up. I'll use the calculator. Actually, let me see. This is 80 plus 99, that's 179. Now, don't forget, each face has a twin. So the total area, or should I say surface area, is going to be 179 times 2. All right, we only did one face at a time. When we did front, back, we just did the front. But it has a front, it has a twin, the front and the back, left and right, top and bottom. So you have to do times 2 at the end. So that is going to be 358. And the units were in centimeters, so for an area, that's going to be centimeters squared. All right, don't forget to do times 2 at the end. All right, volume of a cylinder, pi r squared h. Okay, so this right here is the diameter. That's d. So the radius is going to be half of that. And we know half of 16 is just 8. All right, the volume is pi r squared h. So that's going to be pi. R squared is going to be h squared. And h is your height. That's 24. So in place of h, I'll put 24. On the calculator, I'm going to do pi times h squared times 24. and I get 4,825. If you want one decimal, that's going to be 0.5. The units, there were no units, but if there were, it would be to the third power. Make sure you practice using your calculator, not your phone. All right, volume of the cone, 1/3 pi r squared h. Almost the same as a cylinder, except now it's 1/3 pi r squared h. All right, so this right here is clearly the height, h, and this right here is clearly the radius, r. So that's going to be 1/3 times pi times r squared, so that's 5 squared, times the height, h, which is 8. All right, you can do 1 divided by 3 and hit equals, or you can do pi times 5 squared times 8, and then divide by 3 at the end. So that's what I'm going to do. Pi times 5 squared times 8, and then divide by 3 at the end. You can hit equals and then divide by 3 just in case, and I get 209.4, rounded to 1 decimal. All right, make sure you practice on your calculator. All right, what is the area of the regular polygon? Area is 1/2 apothem times perimeter. Okay, this right here is your apothem. So we'll start with that. The area is going to be 1/2 times the apothem, which is 16.2. And the perimeter, P, is the distance around the circle. Well, each side length is 14. And how many sides? 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. So the perimeter is going to be 8 times 14. In place of P, I'm going to do 8 times 14. All right. So I'll just divide by 2 at the end. 16.2 times 8 times 14. Times 8 times 14. Hit equals, and then divide by 2 at the end. It's the same as times 1/2, and I get 907.2. All right, no units. So that's it. All right, surface area of the triangular prism. You just add up the areas for surface area. So first we have the area of this triangle here. And we know that's 1/2 base times height. So that's going to be 1/2. This will be the height. And this would be the base. All right. So that's 1/2, 6 times 8. Half of 6 is 3. 3 times 8 is 24. All right, now we have this rectangle on the bottom. And that's going to be length times width, or base times height, same thing. So that's just 15 times 8. Whoops, I wrote 18. 15 times 8, that's going to be 80 plus 40, that's 120. All right. And this rectangle right here, we see this distance is 15. And let me do it in a different color. We're doing this rectangle right here. All right, so that's going to be 6 times 15. And that just equals 90. All right, so this one was 90. The bottom one was 120. And the triangle was 24. But we also have the same triangle in the back, so that's 24. Okay, so we have to add those up. All right, so the surface area total is going to be 120 plus 24 plus 24 plus 90. And that's going to be 210 plus 48 is 258. All right, I didn't see any units. If there were units, you would square them, but that's it. So surface area, just add up the faces. Finally, the last problem. Faces plus vertices equals edges plus 2. I'll give you this formula, and it's simple. Faces is represented by the letter F. Edges is represented by the letter E. And we want to know vertices. All right, so just use the formula. For F, plug in 7. For V, we don't know. We're going to leave it. And that equals E, which is 12 plus 2. Okay, 7 plus V equals 12 plus 2, which is 14. Solving for V, the opposite of plus 7 is minus 7. Cancels here, and V is going to be 14 minus 7, which is just 7. Made that a little messy there. V is just 7. So use the formula, which I will give you.